Hello, calculus fans! In the previous video, we did an integration, an iterated integral, in both orders, and we ended up getting the same answer. This is not a coincidence. Remember, we had Clairaut's theorem, which told us that differentiating in either order gives us the same answer. That is, if we compute the second derivative, first with respect to x and then with respect to y, we get the same thing as if we do y and then x. This is true under certain conditions. Now we have a theorem that tells us that integrating in either order will give us the same answer, again, under certain conditions. The theorem in question is called Fubini's theorem, and it says that if you have a continuous function on a rectangle, then if you want to do a double integral over that rectangle, you may compute the iterated integral in either order, and it doesn't matter, you'll get the same answer. Fubini's theorem is actually true if we assume that f is bounded on the region R and is discontinuous only on a finite number of smooth curves and the iterated integrals exist. This will be important later on when we start doing integrals over more general regions than just rectangles. So let's take an example. Let's find the volume that's bounded by the elliptic paraboloid x squared plus 2y squared plus z equals 25, the planes x equals 2 and y equals 3, and the three coordinate planes. So S is the solid that lies under the surface z equals 25 minus x squared minus 2y squared. You see I've just solved for z. And above the rectangle 0, 2 cross 0, 3. So the volume can be computed using an iterated integral, and it doesn't really matter which order we use. So the volume is computed using a double integral. And Fubini's theorem tells us that we may compute this integral using an iterated integral in either order. In this case, we integrate with respect to y and then with respect to x. And if we work out all the calculations, we end up with 106. And this is a volume. Since we were asking for a volume, it makes sense that we get a positive number. We could not possibly have gotten a negative number since it's a volume. Okay, that's all for now.